All right, let's take a look at a couple examples from the homework on 7.3. Let's start with number 14, which is about the Atkins weight loss program. Hey, this is stats and fats. You knew I had to do this one. This is a pretty straightforward confidence interval question, but so they say in a test of weight loss program, 40 adults. So already your little bell should be ringing, and you should say 40. Sounds like a sample size. So I'm picking that out. Here, let's just jot it down here. So I say I got the sample size, n equals 40. Used it. After 12 months, there's a number, but it's not one of the numbers we need. Their mean weight loss was found to be 2.1. So there's a mean or an average of 2.1 and standard deviation of 4.8. Construct a 90% confidence interval. Well, that's a number I need too. So I need 90% confidence interval. For the mean weight loss for all such subjects. Does it seem to work? Is that practical? Okay, let's get the confidence interval first, and then we'll answer the follow-up questions. So let's get StatDisk going here. Let's see, I think I can see StatDisk and those numbers at the same time. So we need a confidence interval. So confidence intervals for a mean. I'm not doing a proportion right now, we're doing a mean. And the confidence level is going to be 0.90. The sample size was 40 people. The sample mean was 2.1, and the sample standard deviation was 4.8. And we do not know the population standard deviation. So we're ready to just hit evaluate and get our 90% confidence interval. So 0.82127. 0.82127. Keep in mind this is pounds lost on the diet. Up to 3.37873. Oh boy, I messed that up. What was it? 3.37873. Okay. So does the Atkins program appear to be effective? Effective? Yes. Was the amount of weight lost 0? It was not, right? They at least lost at the lower end and maybe only 0.8 pounds on average. And on the upper end, maybe as much as a little more than 3 pounds on average. So yeah, average weight loss was a loss. It wasn't 0. Does it appear to be practical? So this is a whole year on Atkins. And they lost on average somewhere between 1 and 3 pounds. We've had some conversations, or Christine will have had some conversations with you by this point about this sort of thing, but is that practical? Maybe. It doesn't seem like a big weight loss. So I'd say probably that's not super practical, and there's probably better things you can do over that 12 months to have a healthy, sustained diet than to do something like Atkins. Okay. And again, they didn't specifically ask for a sentence, but it would be good to practice writing a sentence. So let's write a sentence here and just say, the average weight lost on Atkins is between, and I'm going to round a little bit here, 0.8 pounds and 3.4 pounds. Done. Okay, so good enough for that example. Let's also do a sample size calculation. So let's get rid of this one and let's look at number 26. Okay, so let's see what's going on with number 26. As part of a study of grade inflation, estimate the mean grade point average of all college students in the United States. Okay, so how many grade point averages? So it's a how many questions, so we need sample size. How many grade point averages are to be standardized? Oh, sorry, wait. How many grade point averages must be obtained so that the sample mean is within 0.02 or 0.2 of the population mean? 99% confidence level and a standard deviation of 0.79. Okay, so remind yourself of the formula if you don't have it memorized yet. It had E on the bottom, sigma there, and then the thing that comes from confidence level, the z sub alpha over 2 there, and the whole thing is squared. Okay, so we've got a couple of these pieces already. The desired margin of error was 0.2. Population standard deviation, 0.79. Whole thing's going to get squared. All we need is this z sub alpha over 2 thing. We calculate that the same way we always have. Maybe you don't need this picture anymore, but I'm going to keep drawing it for now. This time we're trying to cover 99% of the curve, which means we're only leaving out 1% total. So that and that together make 1%. Means each one individually is 0.5%. As a decimal, that is 0.005, 0.5%. So we need to figure out what that cutoff right there is. So back to stat disk. And we need to get back to probability distributions, normal distribution, and cumulative area from the left, 0.005. And that means you need to go about 2.5 standard deviations, 2.58, I'll say. So let's put 2.58 in there. Again, technically negative, but since I'm squaring it, the result's going to be positive. Okay, let's get the calculator going. And let's see, we need 2.58 times 0.79 divided by 0.2, that's 10.191, and then we are going to square that to get 104. So sample size, 104 people, or 104 GPAs is what you need. All right, we're done. You're ready to tackle the 7-3 homework. I'll see you on the other side.